Good morning, everyone.
Ma'am.
Okay, so only 20 participants are there. Let us wait for 5 minutes, okay? 5 more minutes we'll wait and then we'll start. Okay, let's start then. Total participant is only 37. Am I audible to all?
Yes, ma'am.
Okay, thank you. Thank you.
Yes, ma'am.
So today we will be discussing about the various components that are used for soil improvement techniques. Okay. So my screen is visible to all. Is my screen visible?
Yes, ma'am.
Okay, okay. So see first here we have components of surface compaction. So for the components of surface compaction broadly it is classified in two categories. First is light soil compacting equipment and second is heavy soil compacting equipment. These light soil compacting equipments are used when the degree of compaction required is less, and when the degree of compaction required more is we use heavy soil compacting equipment. So rammers, vibrating plates, compactors and vibrodampers, they are classified under light soil compacting equipment. And this smooth wheeled roller, ship foot roller, pneumatic tired roller, grid rollers, pad foot or damping rollers, these are the various kinds of rollers, and these rollers are used for heavy soil compacting equipments. Now let us see one by one. Okay, rest of you please mute yourself. You can unmute when I ask for some responses. Rest of you please mute yourself. So about light soil compacting equipments, we'll see about rammers. So rammers are used for compacting small areas by providing impact loads. This equipment is light and can be hand or machine operated. So impact load means heavy load is given, and you know how rammers operate. Okay. So the base size of the rammers that are taken is generally 15 by 15 centimeter or 20 by 20 centimeter. This you can note down for your knowledge. And generally for compacting cohesive soil as well as other soil also you can do this rammer. We can use this rammer, but generally for cohesive soil it is the best one. Then next we see about vibrating plate compactors. Vibrating plate compactors are used for compaction of coarse soil with 4 to 8% fines. These equipments are used for small areas. The usual weight of these machines vary from 100 kg to 2 ton. So here also same, it is light soil compacting equipment, so we can use only for small areas when the area to be compacted is very small. And these vibrating plate compactors are used for coarse soil with 4 to 8% fines. I hope you understand this line. Then vibro temper is used for compaction of small areas. Same thing, small area, since it is light soil compacting equipment. And this machine is suitable for compaction of all types of soil by vibration. So this is about these things, and they are usually the weight generally applied is 50 to 100 kg. The weight of vibrotempers are generally 50 to 100 kg. Next, it is about heavy soil compacting equipment. Under heavy soil compacting equipment, first it comes smooth wheeled rollers. So, smooth wheeled rollers are also classified under two categories, that is, static smooth wheeled rollers and vibrating smooth wheeled rollers. So, the most suitable soil for this roller type are well graded sand, gravel, crushed rock, asphalt, etc., where crushing is required. So, where crushing is required, this type of rollers are used. And static smooth wheel roller and vibrating smooth wheel roller, they are almost same, with just a little bit difference in their construction process. The construction of the machine, that process, it just varies. Okay. The next is ship foot roller. Ship foot rollers are also used for compacting fine grained soil such as heavy clays and silty clays. So I hope it is clear, and there is nothing much to explain. And generally, sheep foot roller, it applies a pressure of 14 kg per centimeter square. Okay, and here a steel drum is fitted in the roller, and with the help of which it operates. The next is pneumatic tired rollers. Pneumatic tired rollers are also called as rubber tired rollers. The total weight of the roller can be increased from 11 to 25 ton. Okay, and these ship foot rollers are used for compacting fine grained soil such as heavy clays and silty clays. Next is pneumatic. Sorry, I was talking about pneumatic tired rollers. So, pneumatic tired rollers are used for compaction of coarse grained soil with some fines. Then, grid rollers are used for compaction of weathered rocks and well graded coarse soil. Then pad foot roller is also, these rollers are similar to ship foot roller. So ship foot roller and pad foot roller or tamping rollers are almost same, only what with the difference that lugs are fitted in the with lugs of larger area than ship foot rollers. So the lugs that are fitted in the tamping rollers are of greater size than ship foot roller. Next, we move to components of soil reinforcement. So here we have mainly three components, that is soil. Everyone, soil will be there, and then facing element and reinforcement. The spacing element is the structure or the part which holds the reinforcement part. Okay, this is the main part. The facing element is the main part. and all the reinforcements that are fitted to the that are inserted inside the ground, they are fixed to this facing element. So the soil has to get few characteristic that after application of this technique, that it should develop sufficient friction between earth and reinforcement. Then no interstitial pore water pressure develops within the reinforced earth structure. These characteristics should be there after the application of soil reinforcement. Okay. The placing and compaction of the earth fill layers can be accomplished easily. The soil must conform to certain electrochemical condition to avoid corrosion. So corrosions should not be there. That is what. Rest point, I think it is clear. It is written in simple language only. Then facing element also should retain the backfill between the layers of reinforcement. So obviously it should retain the backfill, right? Since this is the main element or main structure which holds the reinforcements. So this has to be there. It should retain the backfill. The backfill should not fall into this. Okay. Then made of either metal units or precast concrete panels. This facing element, it is made of either metal units or precast concrete and should be able to deform without distortion. Flexibility should be there little bit, but it should not get distorted or for the loads that is applied. Then comes reinforcement. Reinforced members are composed of thin white strips, also called ties. Everybody is familiar with ties. You have studied in structure. Then should be flexible to ease placement. Means while placing the reinforcement, it should be flexible enough. And then should have adequate tensile strength, should have adequate service life, taking into account corrosion and weathering. These things are normal. These characteristics are normally expected from all kinds of reinforcements. Next we come to the components of grouting. So grouting we need what syringe is required. As I told you, grouting, it is the process where the chemicals are inserted or injected inside the pore space or inside the subsoil structure. So for injecting, obviously we need a syringe, and jet grouting a type of grouting. Okay, and it is the most developed one. The modern method of grouting nowadays is jet grouting. We will study about the types of grouting in the chapter. Separately it is given to you, grouting. There will study, and for now you know that jet grouting is a type of grouting, and it is the most modern technique nowadays. And for this string of almost 7 to 10 centimeter diameter is required, and the end of this string a nozzle is fitted to have an injection at a higher velocity. Okay, the nozzle diameter, it ranges from 1 millimeter to 10 millimeter. Next is component of chemical stabilization of soil. So, for chemical stabilization, we need various chemicals. Either one chemical we can use depending on the situation, depending on the type of weakness the soil has. Okay, or sometimes more than one chemicals are also used, two or more, three, four, or whatever number of chemicals are mixed to get much strength, and then it is mixed with the soil for stabilizing the soil. So some chemicals are written here. Calcium chloride, being hygroscopic and deliquescent, is used as water retentive additive in mechanically stabilized soil bases and surfacing. So calcium chloride, it is hygroscopic in nature. So it can retain water, and so if the site has some condition that we need to retain the water, so there we can use calcium chloride. Sodium chloride is other chemical that can be used for this purpose with stabilizing action similar to calcium chloride. So calcium chloride and sodium chloride is almost has got some similar few similar characteristics. Then sodium silicate is also another chemical, okay, we can use. And also we use other chemicals which are not written here though, like cement, we know, you know the properties of cement. Then fly ash, lime is also used. So various chemicals are there we can use, and sometimes we can mix them and we can use for better performance. So that is all about the components that are used in ground improvement techniques. Any doubt till this much? Anyone can ask. Anybody having any doubt? Yes or no? Clear, ma'am. Yes, ma'am. Yes, ma'am, for what? No, ma'am. No doubt. Anything else you want to add from your side? You're most welcome.
Ma'am, I just joined, ma'am.
Hmm. Join the meeting.
Yeah, ma'am, I just got to join, ma'am. I was trying to join like around 20 minutes ago, but I just got to join in.
Okay, fine. Since I was sharing the screen, so it was not possible for me to admit you.
For me also, link was hard to get, man. I asked from a friend and I got, but when I joined, the link
Why
I was
link
not
was
able
hard?
to
I
join
shared.
in.
I shared the link in the group, right?
There's lots of links, ma'am, so it's got little confused to find it.
Okay, fine. No problem. You can see the recording later on when I upload in the ERP. Okay.
Okay, ma'am.
So remaining who were attending, anything you want to add from your side, you can. Nobody. Will you share the PPT? You need the PPT. Notes will get, detailed notes will get in the portal. And if you want PPT, you can get after a few days. I will be uploading the link. This the YouTube link is there. I will upload the YouTube link and their PPT along with my recorded voice is there. Explanation is there. You can get, but this will be available from my side only after a few days. Is it okay?
Okay, ma'am.
Okay, fine. Then let us move to the new next topic. Okay. So next is engineering properties of soft, weak, and compressible deposit. So what is soft, weak, and compressible deposit? What do you understand when you say this? Any idea what kind of soil it is? Soft, weak, and compressible? Anybody? Any response? Clay. Pallab Talukdar. Okay. Then anything other than clay? Yes, Vicky, soft soil, it is written already. So what kind of soil it is, I'm asking. Pallav has answered clay. Anybody else? Anything? Sand. Yes, sand is compressible. Okay, fine. Thank you for your responses. So you see, certain types of ground contains layers of very soft materials like peat. Peat soil, you have heard what it is? Peat. What kind of soil it is? Any response? Yes, ma'am. No, ma'am. No idea. Anybody else? No. No. Okay. So, peat is a kind of soil that is formed from organic deposit. Okay. We dispose the organic materials like sometimes organic materials, example, you can take the waste generally from the kitchen or the vegetable waste like this. Okay, and many other are there. At present I'm not getting. So the when we deposit lots of these things, it gets converted to soil, and that kind of soil is called as peat. And this kind of soil is very soft. And clays, though you know already. So see, all kind of ground or soil are not suitable for construction. They are very soft, they are weak, and also compressible sometimes. So these three properties, that is soft, weak, and compressible, the soil may possess any one characteristic. Either it is soft, either it is compressible, or it may possess all the characteristics soft. And if generally if it is soft, it will be weak, it will be compressible. Okay, so this there will be a problem if we start constructing on this kind of soil. So some kind of improvement is required. Okay, and what are their engineering properties, we'll study this. So next you see, these layers are likely to get to compress if they are loaded by overlaying structure, or if the groundwater level changes around them. That is what I told you. This compression may result in depression appearing in the ground surface or under structures, potentially damaging foundations and services. Obviously, if we construct on the so that on that kind of soil, something heavy structure we construct, then what will happen? Settlement will be there, and there are chances of differential settlement also. And ultimately there will be depressions in the structure, there will be cracks, then the foundation will get damaged, the walls will get cracked, the services will get broken, these things. Okay, now why does it occur? So many ground materials contain water-filled pores. Water-filled pores means the pore space that is there in the soil are filled with water. Okay, so because of that also the problem arises. When the pores are filled with much water, then the soil attains the ability to get compressed. Then peat, alluvium, laminated clay, some silt, and sand are the types of deposit commonly associated with various degrees of compressibility. So these are the some types of soil that is named here. They are, they come under this type of categories. Okay. So these are the few methods of ground treatment that can be adopted for various poor ground condition: vibratory surface compaction and deep vibro compaction. Then removal and replacement of soft cohesive deposit for limited thickness. Again, these things already it is discussed in first unit only, but it is just specified that this for this weak deposits it is just specified here. Otherwise, these are the normal processes we use for ground improvement. So removal and replacement, already I told you that if the area to be changed or the limit thickness is very less or the area is less, then we can do one thing, we can just remove the soft soil and then we replace it with good quality compacted soil. Then preloading of existing soft or loose fill. Preloading also it is same, preloading with vertical drains, dynamic replacement, stone column, piled embankments in areas having soft soil to large depth, viaduct for high embankments on ground having very deep soil with organic deposits. So let's see one by one. So here comes vibratory surface and deep vibro compaction. So surface vibratory compaction is used for densification of loose cohesionless soil using vibratory roller. Same vibratory rollers are there with the help of vibration. The loose soil, the loose cohesionless soil means it is meant here generally the what kind of soil? Loose cohesionless soil. Anybody? What do you mean loose cohesionless soil? What kind of soil it is specified here? Yes, anyone? Sandy, sand. Okay, yes. So generally, if we apply vibration to the sand, it will get densified. So with the help of this vibratory compaction, this thing is done. Okay, deep vibro compaction can be done for loose sandy deposit having less than 15% fines for depth up to 10 meter. If the depth of the soil, that is the sand, is up to 10 meter, then only we can apply this method. So these points you can note down. Okay. Then compaction is carried out by inserting the probe up to the design depth of improvement and allowing the soil around the probe to get compacted for certain time interval. Then the probe is raised by about 0.5 meter to compact the soil around the vibrator and the process is repeated. So probe means what I will say now. Anyone any idea about probe? No. Okay, some type of rod like structure you can say, but the end is not sharp, the end is blunt. Okay, and it is inserted inside the soil and then some vibrations are applied and then the rollers are run into the surface. Then with the help of this vibration the compaction work is carried out. Okay, it is a rod like structure with the where the end is blunt, not sharp, it is blunt, it is inserted. Clear? Then removal and replacement. So for localized areas, already I told you about removal and replacement. So here you can see for localized areas with soft soil of limited depth and thickness, removal of unsuitable material and replacement with suitable fill may be carried out. The removal and replacement may be required to be carried out even in cutting areas where the naturally occurring soil were found to be of low shear strength and high moisture content. That is what I told you before, that the unsuitable soil is removed and it is filled with the suitable soil only if the area and the depth is small. Then preloading. Preloading of soft soil is based on consolidation concept. For low embankments over soft compressible soil where the pore ground is of limited thickness or is capable of compressing rapidly under load of excess preload field due to presence of sand lances, preloading may be resorted. So preloading, anybody can say anything, because in previous classes I gave a bit idea. Little bit idea was given about preloading. Anybody? Anything you can say about preloading? What it is? What is preloading? Pre-applied stress. Anybody else? Filling the hole with gravels. No. Preloading stress, that somebody answered just before, it's partially correct. You can say it's correct almost. But not filling the holes, that is not correct. Any other response? No other responses. What happened? Are you guys there or not? Or you have just connected and left?
No, ma'am.
Okay, you guys are there. Fine. Okay, fine.
Yes, ma'am.
Preloading. Preloading, the name itself says. Pre means what? Before. And loading means what? Application of load. So, before construction of any structure, some external loads are applied to the soil. Suppose if the soil is very much compressible or it has got poor water problem, then what is done? Load is given to the soil so that the excess water is drained off, and then after application of the load, after the for some time, some period, some certain period, this loading is kept, and after certain period the required compaction is achieved, and then the load is removed, and then compaction work is carried out. That is what is preloading. Clear? Okay, this part will let us stop up to preloading here today, because the meeting is going to end. The rest part will continue in the next class.
Okay, ma'am.
So till then, any doubt if you have, you can ask. Anybody having any doubt, you can ask till this meeting ends. We have only 3 minutes, I guess.
Ma'am, can you explain preloading? Again, I logged out suddenly, ma'am.
Okay, preloading is the name itself says pre and loading. Pre means what? Before. Loading means application of load, right? So, what is done before construction of any structure? Suppose the site is not good, it is soft or compressible, then some kind of external loading is applied to the place, and that loading is kept for certain period, so that if there is excess pore water, it will be squeezed out or removed out. Okay, and after the required compaction is achieved, then the load is removed and construction work is started. Clear?
Okay, thank you.
What about compaction ruler that fine?
Yes.
compaction ruler appliance.
Compaction roller.
Yes, ma'am. For sand and mud.
I
Okay.
have shown various kinds of rollers, and various kinds of rollers are suitable for different kinds of soil. So you see there what kind of roller is suitable for sand, what kind of roller is suitable for clay soil. It is given. Can you elaborate more on probe compaction? Actually, Vicky, it is not probe compaction. The probe is a part of the roller, of the part of the roller. Okay, it is just a part of the roller, and this probe, it is inserted inside the ground, and vibration is applied. I told probe, it is a that ground rod like structure it is, and it is inserted inside the ground and vibration is given. Okay, and because of this vibration, the loose sand, generally the sandy soil, we can say it gets compacted, and then we can run the roller upon